my name is Raphael Pedersen, and for my ENME 351 final project I made a self-balancing robot. It's powered by a 12-volt battery and actuated using two motors that each control a wheel on either side of the robot. On the back is an Arduino Uno and an L298N motor controller H-bridge. They're used to control the motors. And on the bottom is a MPU 6050 IMU/gyroscope that's used to measure the angle and angular velocity of the robot. So if we put the robot down on the ground and we turn it on, it will start balancing itself with its very musical motors. And you can see that's able to stand up, and you can push it a little and it will stay balanced. And if we turn it back off, you'll see that it just falls right over in either direction. So it's unstable on its own, but when the robot's turned on, then it's perfectly capable of standing up on its own. Next, if we connect the USB cable into the Arduino, then we can go into processing, and we're able to view the robot's orientation on the left and the different components of the voltage going to the motor on the right. So first, for the robot's orientation, you can see if I pick up the robot, it looks a little angry, but when I tilt it forward, it moves forward. When I tilt it back, it moves back on the graphic. Then if I put the robot back down, on the right here, you can see the motors can be given between 0 and 6 volts, but there is a constant 2.2 voltage that's given in order to overcome frictional losses. Then from here, a PID loop is used to control the robot's orientation. So green represents the P component of the voltage, blue represents the D component of the voltage, and yellow represents the I component of the voltage. So if I start pushing on the robot off screen, then you'll see that the P, I, and D each start showing up. Sometimes they agree with each other and sometimes they point in opposite directions. And the white line represents the output that's given to the motors in the end. Once the constant voltage, P voltage, D voltage, and I voltage are all taken into account. And on the top you can see whether the output is positive in red or negative in blue. You can also see the raw value of the voltage that's being given to the motors. Here's some additional footage of the robot balancing without the cable attached to it. It doesn't make too much of a difference whether the cable is attached or not, but this is just to show it that there's nothing really supporting it other than its own balancing. And it does a pretty good job, though. Again, if you push too hard, it starts running off in one direction until it falls over, and then it can't get back up.